Hi, this is D. Rambabu. I am working as an assistant professor in the Department of Science and Humanities in University College of Engineering. I am going to explain the subject probability and statistics. If you have any doubt after watching my complete video, please comment under this video.
Okay, student, Bayes theorem. It is very important theorem in probability and statistics. Okay, there are so many problems basing on this theorem. Okay, Bayes theorem. Okay, its statement is given by suppose E1, E2, En are mutually exclusive events of a sample space S such that probability of any event Ei is greater than 0, I is equal to 1, 2, 3 and so on n, and A is any arbitrary event of sample space S such that probability of capital A is greater than 0, and there is a condition that is A is subset of union of I is equal to 1 to n Ei, then conditional probability of Ei given A for I is equal to 1, 2 and so on up to n is equal to probability probability of Ei given by A is equal to probability of A given Ei into probability of Ei by summation of probability of A given Ei into probability of Ei. Okay. Here in this theorem there are n events E1, E2 and so on an. They are all mutually exclusive events, that is Ei intersection Ez is equal to phi for any values I and j. I is not is equal to j. E1 intersection E2 is equal to pi, E2 intersection En is equal to pi, E1 intersection E3 is equal to pi. In this way they are all mutually exclusive events of the sample space. Okay, and also there is another point, that is A is union of I is equal to A is subset, A is contained in the union of these events. Okay, A is subset of union of I is equal to 1 to n Ei. Okay, here we need to prove that probability of Ei given A, probability of this event given by this arbitrary event is probability of A given Ei into probability of Ei by summation of probability of A given Ei into probability of given Ei, probability of Ei. Okay, let us prove the theorem. Okay. Okay, in the statement given that A is contained in union of I is equal to 1 to n Ei. A is subset of union of I is equal to 1 to n Ei. Okay, then what is the intersection of this event A and this event union of I is equal to 1 to n Ei? That is A intersection union of I is equal to 1 to n Ei. Okay, what is the intersection of A and this set union of I is equal to 1 to n Ei? You know, when A is subset of B, then A intersection B is given by A. Okay, here the A is smaller set than B, therefore A is contained in B. Okay, A intersection B will become A. The common elements in both A and B will be the elements of A. Therefore A intersection B is equal to A. Whenever A is contained in B, we have to choose smaller set. A is smaller set. Here also, since A is smaller set, A is contained in union of I is equal to 1 to n Ei, we have A. Okay. Next. Now, therefore, and that is A is equal to A intersection union of I is equal to 1 to n EI. Okay. Here again we will use distributive law. Okay. By using distributive law, this can be expressed as union of I is equal to 1 to n A intersection EI. A intersection EI. This is by distributive law. Distributive law. Okay. Next, given that also we have events E1, E2 and so on, En are mutually exclusive events. Okay, that is EI intersection EJ is equal to phi for I not is equal to j. Okay, therefore whenever E1, E2 and so on En are mutual exclusive events, then we have also A intersection E1, A intersection E2 and so on, A intersection En are also mutually exclusive. That is, they are disjoint each other, they are mutually disjoint. That is, okay, that is A intersection EI, okay, intersection A intersection EJ is phi for I not is equal to j. Therefore, A intersection E1, A intersection E2 and so on A intersection are mutually exclusive events. Okay, when two events are mutually exclusive events, what is the probability of their union? That is, here A is mutually exclusive, A and B are mutually exclusive, okay. It implies that probability of A union B is given by probability of A plus probability of B. Okay, that is, actually by addition theorem we have a probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. But here A and B are mutually exclusive events, so therefore A intersection B is equal to phi. It implies that probability of A intersection B is 0. Therefore, because probability of null set is always 0. Probability of null set is always 0. Therefore, this term will become 0 in addition theorem. Therefore, we have P of A union B is equal to P of A plus P of B. Here also, now let us consider probability on both sides of this equation. Okay, that is, probability of A is equal to probability of union of I is equal to 1 to n A intersection EI. Okay, that is probability of, split this expression as A intersection EI. I is
from 1 to n. Therefore, A intersection E1 I is equal to 1 to n 1 plus union A intersection E2 I is equal to 2 plus and so on up to P of A intersection En. Okay. But since A intersection E1, A intersection E2 and so on, A intersection En are all mutually exclusive events, we have P of A intersection E1 plus P of A intersection E2 plus and so on up to the term P of A intersection En. Okay. This can be written in short form as using the symbol I is equal to 1 to n, summation I is equal to 1 to n. Okay, probability of A intersection Ei. Here I is from 1 to n. This is probability of A. Okay. But here A intersection Ei, P of A intersection Ei can be written as P of A intersection Ei P of A intersection Ei can be written as P of A given Ei into P of Ei. Okay, this is because P of A given Ei, as per the formula of conditional probability, we can write down as P of A intersection Ei by P of Ei. Okay, here we want P of A intersection Ei. P of A intersection Ei is equal to P of A into P of A given Ei into P of Ei. That is why we are writing P of A intersection Ei as P of A given Ei into P of Ei. Okay. Therefore, we can write P of A is equal to sigma I is equal to 1 to n. Replace probability of A intersection Ei with P of A given Ei into P of Ei. Okay, P of A given Ei into probability of Ei. Okay, now we need to find out the probability for Ei given A. Probability for Ei given A. Okay, but by the formula of conditional probability, we have P of A intersection Ei by probability of A. Okay, but here we know that probability of A intersection Ei is given by P of A intersection Ei is given by probability of A given Ei into probability of Ei divided by P of A. Here P of A is given by sigma I is equal to 1 to n P of A intersection Ei. Okay, sigma I is equal to 1 to n P of A intersection Ei. Again, P of A intersection Ei means P of A given Ei into P of Ei. Okay, therefore we have P of A given Ei P of Ei by summation I is equal to 1 to n
P of A given I, okay, replace P of A given I with P of A given EI into probability of EI. Therefore, we have proved the theorem P of A given EI is equal to probability of A given EI into probability of EI divided by P of A given EI into probability of EI. Okay. Therefore, this is very useful theorem. Okay, very important theorem. In many examinations, it may be asked. It is asking thoroughly. Okay, there are so many applications basing on this theorem. Okay, base theorem. Okay.